Let's cover a few more swarm options and reinforce the ones we've already discussed. If you type swarm dash dash help on the BioWolf command line, you get a list of all options available to swarm. And there's a lot of them. So let's just go through the ones that a new user is most likely to need. There's dash F and the name of a file. And this is the swarm input command file that contains a list of commands to be executed, one per subjob. This is a required option, and it's the only required option for swarm. There are some options that relate to the resources required for each subjob. And that's the dash G flag, which is the number of gigabytes of memory per process. The dash T flag, which is the number of threads per process. And of course, this is only meaningful for a multi-threaded application. And dash M or dash dash module, which is a list of one or more environment modules that you want loaded before each subjob runs. There are some options which relate to how the individual commands are packed onto the allocated resources. And one of those is the dash P flag, the number of processes per subjob. By default, this is 1. And this is only meaningful for a single-threaded application to set it to any value other than 1. So for a single-threaded application, when you set dash P equals 1 or you leave it at the default, then Swarm will set up your jobs so that one command in your Swarm input file will run on each allocated core. The core has 2 hyper-threaded CPUs, if you remember. So you can also set dash P to 2, and then Swarm will pack 2 processes, that is 2 lines from your Swarm command file, onto each core. And these 2 commands will run simultaneously, one on each hyper-threaded CPU of the allocated core. There's the dash B flag, which is bundle, and that will be covered in a later video. Swarm expects bash syntax by default. If your Swarm command file contains CSH syntax commands, such as setting environment variables, you might want to require that Swarm set up CSH syntax batch scripts, and then you'd use the dash dash use CSH option to Swarm. There are some more options to Swarm. Let's just talk about a few of them. One of them is dash dash partition, which means instead of submitting to the default norm partition, you can set it to submit to some other partition that you prefer. There's dash dash dependency, which we haven't covered yet, but that's a matter of setting up a swarm to run before or after another specified job. So you might want that if you're running pipelines. And that's covered in more detail in a later video. Dash dash time, which specifies the wall time for each subjob. By default, that's 4 hours, but you can set it to be more or less as you need. Dash dash logdir specifies the directory to which the swarm.o and .e files are written. By default, they turn up in this directory from which you're submitting the jobs. And dash dash max running. That limits the number of simultaneously running subjobs. Suppose you submit a swarm of 100 subjobs. If the cluster is not busy, they might all start up all at once. And suppose those jobs are doing a lot of input-output. So they're reading or writing a lot of data. Then those jobs could put quite a load on the file system. And in that case, we might ask you to set max running to some lower number so that only a smaller number of those jobs run at any time. Let's work our way through an example. Here's a swarm command. It starts with swarm-f swarm file, which, as I've said, is a required option, the name of the swarm command file that contains all the commands you want run in the swarm. T12 means allocate 12 CPUs per process. And presumably this is a multi-threaded application, and within the swarm command file the application is set up to spawn 12 threads for each process. G6 means allocate 6 gigabytes of memory per process. Module ABCD means load the module ABCD before each swarm subjob. And logdir job out. That means put all the swarm.o and .e files into a subdirectory called job out. By default, they would have appeared in the directory from which you're submitting the job. And you can also add sbatch options to the swarm command. In this case, it says --sbatch, open quotes, --mail type equals fail, and close quotes. And that's a slurm sbatch option. And that means send email to me if the job fails. And this is a little dangerous because if you have a swarm of 1,000 jobs, for each job that fails, you'll get one email. So you want to be careful when you use this. People are often confused between sbatch and swarm. When should they use what? And what's the difference between them? And this slide may help to make that clearer. Sbatch is the built-in Slurm batch system command to submit jobs. Swarm is a sort of shortcut that will set up the batch scripts for you and submit it to the batch system using sbatch. So in effect, both of them are using sbatch. Swarm just might make it a little easier for you to submit large numbers of jobs. If you're submitting an sbatch job, you write your own batch scripts. If you're submitting a swarm job, you simply write a file containing a list of commands. Sbatch can be inconvenient for large numbers of jobs. For each job that you submit, you'd have to write a batch script. Swarm is very convenient for large numbers of jobs. You'd write a simple script that writes a long swarm command file and submit it with Swarm. Swarm will then create the batch scripts for you. Sbatch makes it relatively easy to debug a failed job. What that means is if a job fails, you know the job ID, you can immediately look up the job script that it corresponded to, and you can debug the problem. With a swarm, a large swarm in particular, if you have 500 jobs and 3 of them fail, the subjob number 3, 18, and 72, for example, it can be a little more work to figure out which commands those corresponded to, why they failed, and how you should fix it. So again, Swarm is very convenient for large numbers of jobs, and it's your choice whether you use sbatch or Swarm, but more than 50% of the jobs submitted on the BioWolf cluster use Swarm.